Okay, hello everyone. Thank you for coming, especially that's Saturday and after lunch. So I understand that you may be tired already. So my name is Patrycja, and today I'm gonna walk you through some corner cases and traps in Prometheus. A little bit about myself. I've been doing professional software development for over 25 years. Last couple of years, I spent as a site reliability engineer in a fintech company. So when money is involved, you always need like an excellent observability. And that's the source and root cause for today's talk. Dealing with Prometheus for a couple of years, I learned the corner cases and gotchas. So what am I gonna talk today? A very short introduction to Prometheus, and then I will show you 6 puzzles which showcase some traps, pitfalls, and gotchas in Prometheus query language and Prometheus itself. Moreover, I will try to introduce some best practices how to deal with those problems. You may have noticed yesterday that I do enjoy interactive presentations. So today I also have some engagements, and I will love your help. So I have the Slido puzzles and polls prepared. This is a Slido warm-up now. So if you could please scan the QR code and tell me a little bit about yourself. What's your role? What you are interested in? Hopefully you are close to observability and Prometheus itself. But basically today, in any technical role, you touch some kind of observability. No matter you are DevOps, software engineer, or platform engineer, observability is like a must. Oh, I see that software roles are the most prominent here. So I'm not sure if you are only like dealing with software development itself, whether or not you are doing on-call rotas, but most likely you access some dashboards and create some dashboards yourself as well. So that might be useful for you. So thank you for your answers, and be ready because we will have more polls later on during the talk. But let's start what observability actually is. If you are much younger than me, then perhaps you didn't experience such a behavior as on this slide, because it happened to me like 20, 25 years ago when software engineering practices were not existent, definitely not as major as they are now. So it happened to me that basically our production system went down and only our customers calling, calling on a phone, they let us know that something's wrong. So such answer like, oh, is it broken? Since when? So it happened. It happened to me, and I learned the hard way that observability is a must. At the time, 20-something years ago, we didn't have so many open source and free observability tools available. So we cooked up some in-house system, and we were not surprised anymore by when our our application going down. Nowadays, we have 3 pillars of observability. Those are metrics, logs, and traces. And all 3 of them are equally important. However, when it comes to like solving some problems or alerting on some issues in our applications, usually we rely on logs and metrics. Traces, I think, are less popular. And Prometheus is part of the most popular observability stack. Prometheus serves as a metrics database. So we do have some choices out there when it comes to observability. When it comes to free and open source software under CNCF umbrella, Cloud Native Computing Foundation. So we have this Grafana, Prometheus, Loki, and Tempo observability stack. Also, there is another pretty popular ELK stack, Elasticsearch, Logstash, and Kibana. We have another commercial solutions when it comes to application performance monitoring. Also, we can have some sort of hybrid solutions when we use Prometheus for metrics, Grafana for visualization, and for example, ELK for logs. That's what I happened to see and in the real world configurations. How does it look like in practice? How is the flow? So we have an application. The application records some observability data. Nowadays, it's popular to use OpenTelemetry as an SDK for any observability. Then we have some sort of data collectors that collect telemetry data from different sources. Again, nowadays, OpenTelemetry is the most popular choice. It processes the data, collects the data, processes the data, and exports them into backend storage. And this backend storage, usually it's separate for metrics, traces, and logs. And then in the end, as usually end users, we use some sort of visualization, dashboarding solution like Grafana to see those data. In terms of metrics, they come usually from Prometheus data source. We also have some sort of alerting with Prometheus. You have Alert Manager. So from our perspective as developers, we are interested in how we visualize data and what alerts are configured and how we can configure alerts for our applications. So let's move on to Prometheus. As I mentioned, Prometheus is a metrics database. This is a CNCF graduated project, free and open source. Underneath, we have time series database. What does it mean? This is a database optimized for storing and querying data points that change over time, like metrics, exactly. Prometheus comes with PromQL language. This is a query language. We can query the data. And it turns out that Prometheus is not that simple, especially its query language. But just to refresh our knowledge on key concepts in Prometheus, we have metrics. Metrics are basically numeric time series. We have 4 metrics types, like counter, gauge, histogram, and summary. Each metric has its unique name. We can associate labels with metrics, so we can have extra dimensions added to a given metric. Like for HTTP request total, we can have label method and handler. We can configure scraping for Prometheus. Scraping means that Prometheus pulls metrics from endpoints at regular intervals, and targets are defined in the config. Time series is a unique combination of a metric name and labels, and it's stored with a timestamp in a storage. And as I mentioned, PromQL is a query language for selecting and aggregating time series. As I mentioned, my first experience with Prometheus was like, oh, it's a piece of cake. It's so easy to use. I can visualize data with Grafana and Prometheus query very quickly. It's like, I'm happy. But over the time, when I was working more and more with Prometheus, and I ran into several corner cases, I got more and more frustrated. So it turns out it has hidden complexity. So let's try to navigate this maze together, and let's go over several corner cases and puzzles when it comes to querying and working with Prometheus. So let's start with quanti-illusion. When it comes to Prometheus, you often use histogram metrics. Histogram is basically a series of buckets, and we record how many, and we record our observations, our data as basically how many times they fall under each bucket. And those are very important when it comes to monitoring performance, like application response time. Often our SLAs or SLOs, service level agreements or service level objectives, are defined in terms of percentiles or quantiles. So for example, that our P99 can't exceed 100 milliseconds. So it means that 99% of our requests can't exceed 100 millisecond execution time. Here we have a simple code that records an example histogram metric, actually 2 metrics, A duration second and B duration seconds, both with constant observation. Constant observation, it means that it always says that our A duration is 500 milliseconds in one case and 900 milliseconds in the second example. So basically, as you see, constant observation just adds predetermined number of observations to our collector. So here comes our first puzzle. We have those 6 buckets. We have 100 millisecond bucket, 200 millisecond, 300 millisecond, 400 millisecond, and 1 second bucket. This plus infinite bucket is by default always added. So in total we have 6 buckets. and 98 observations. All observations for each metric are the same. A duration 500 milliseconds, B duration 900 milliseconds. And now we want to use this very useful histogram quantile function in Prometheus, which basically should say 99 quantile for A duration metric and B duration metric over 10-minute interval. And the question to you is, what will histogram quantile return for each metric? And we have several answers here, because the first one is like based on the real data. When it comes to, when we have constant observation, each quantile is the same, and 99 quantile would be 500 milliseconds for A duration and 900 milliseconds for B duration. The answer B is 994. It looks pretty cryptic. Perhaps Prometheus will round it up to 1 second for both metrics. Perhaps it won't return anything as the answer D says, because we don't have enough samples. Perhaps 98 samples are not enough to calculate 99 quantile. Or perhaps it will return error, as the queries are incorrect. However, I can tell you the queries are correct. Okay, so time for you to think about this and give me your choices. Please go to Slido and try to choose between those 5 choices. And I see 994 as the first choice. Any other choices? We only have 2 answers. I would love to see more. No data, as there is not enough sample. Here, we are getting more diverse choices. However, you are very, very smart audience, because 994 is your top choice. That's the correct answer, I can tell you. And that's the first time it happens that the audience answered correctly, because I got more diverse choices in my previous rounds of this presentation. So yes, 994 is the correct answer. And why? First of all, histograms do not contain actual values, only the counts in buckets. So basically, Prometheus is not able to answer correctly. It can only estimate. So basically, histogram quantile looks for the right buckets where the desired quantile falls, and then performs linear interpolation using uniform distribution. So in our case, both histograms have exactly the same data, because 500 and 900 milliseconds, they fall in the same bucket. A duration and B duration metrics are the same. And looking at linear interpolation with uniform distribution, it gives us approximately 994. And that's the answer from Prometheus. Let's continue with quantiles, and let's take a look at the second puzzle. We have 6 buckets. We have 100 observation, and they all fall. They all are constant. 1,500 milliseconds. So basically, they fall in the last bucket, right? So again, we have exactly the same query. We want to find out 99 quantile for C duration metric. And we have a problem here, right? Because I explained to you that Prometheus uses linear interpolation for a given bucket. But in this last bucket, we don't have this upper bound. So the question is, what will Prometheus do in such a case? It can do this interpolation based on 1 millisecond lower bound, 1 second lower bound and max int, or 1 second as a lower bound and upper bound as max float, or perhaps C, 1 second, or not a none, since it's unable to approximate. So what's your choice here? Again, let's use Slido and see what our audience thinks. Not a number. That's always like sounds like a safe choice, right? Because we are not able to estimate. Prometheus uses floats or doubles everywhere, so this max double might be a safe bet as well. And nobody has chosen 1 second, and I can tell you that's the correct answer. So I was able to trick you. 1 second is the correct answer here. And it happened to us in real world many times when we had some incident and we saw, for example, our system running at 30 seconds. This was like our highest bucket, real bucket, this 30 seconds. But actually we couldn't say how bad our system performed at the time because we were not able to estimate this with Prometheus metrics. This is a special case, and it's explained in Prometheus documentation. If a quantile is located in the highest bucket, this means this plus inf, the upper bound of the second highest bucket is returned. So basically, the highest real bucket is returned. So we need to remember that histogram quantile is only an approximation. We need to design our buckets to cover our distribution, and we can use more buckets when better accuracy is needed. However, we need to keep in mind the costs. Because more buckets means more data, and depending on your configuration, it means more storage space needed, or basically more cost if you use any cloud solution or a service, our Prometheus or observability as a service solution from some provider. Also, when it comes to SLOs and SLAs, it's important to formulate them around percentages instead of exact values. So instead of using like our P99 request duration should be not more than X milliseconds, it should be formulated as percentage of requests, because that way it's clear and it doesn't cause any problems when it comes to customer communication or observability, internal observability. We had the cases when, for example, even though our SLAs were formulated in terms of percentages, our customers received those quantile values as well, and they were worried when they fluctuated. And it was very difficult to explain that this is only an approximation. So we are not showing you the exact values. This is an approximation under our like SLA boundary, but still, and this is just for better visibility, but it turned out like to be a bad choice. Okay, let's move on to extrapolation in Prometheus. This is also confusing, as you can see from the title slide. So we have this counter metric this time. The counter is increased every 60 seconds, so basically 1 minute. We have 1,000 samples, and scraping is every 15 seconds. And then we want to use, again, handy function from Prometheus, PromQL, increase, which should show us an increase in a given interval. So we are providing this 90 seconds interval. And what we expect is that it should return more or less free, right? Not free, one, sorry. One, because when we increase the counter every 60 seconds, so in each 90-second interval, we have only one increase. So the question, again, we have 4 choices. A is 1, B is 1, plus minus epsilon, as increase uses rate underneath, and rate uses floats, so we can have some small fluctuation. C, anything from the range of 0 and 3. And D, it depends, it can return not a number or 1 with epsilon. So please choose your bets. I'm really looking forward to your answers. I may already advise you that the obvious choice might not be the correct one, because as you know, I've chosen like corner cases here. Oh, so we have like pretty even split, not so much. We have anything from 0 to 3, and yes, you are right again. That's anything from 0 and 3. And why? Because you can see like the actual proof. That's how the graph looks like visualized in Grafana. And you have the explanation here. Basically, if you take a look at the Prometheus source, you can see that underneath increase uses rate, and underneath it uses this extrapolate rate function. And explicitly, we have a comment here which says that it extrapolates if the first or last sample is close to the boundary of our interval. So that's why we have this fluctuation. So you need to be very careful when it comes to using Prometheus as the source of accurate data. Metrics are not accurate. They should show the trends, but you shouldn't rely on them to get exact data. When you want exact data, go to your logs, or you need to like implement a different system. And you need to be careful with anything rate related. Rate, I-rate increase. The increase is only like a syntactic sugar over rate. So all these 3 functions the output changes based on the evaluation interval. Also, it's important to align scrape and interval values. And the best practice is to use for your evaluation interval in queries as 4 times of scrape interval. Moreover, because of that, you shouldn't use like absolute values when it comes to alerting. You should alert on anomalies instead of like exact values, because those exact values are never exact when it comes to Prometheus querying. Okay, let's move on to another puzzle, the 4th one. We have counter, this error counter. We have only a single increase, no samples before, and scraping every 15 seconds. And the question now is, will our alert fire? We have this alert, increase error count over 5 minutes, greater than 0. So this is a simple query. When we see an error, we should fire an alert. So we have 4 answers. Yes, it will fire immediately. Yes, it will fire, but with 5-minute delay, since the evaluation interval is 5 minutes. No, it won't fire, just like that. And the alert won't fire, but Prometheus will notice the error and fire its own alert. So let's use Slido again and see your bets. Yeah, you can already notice a pattern that the obvious answer is not correct. So yes, this alert will fire immediately. Does it sound good? So something like, so we have an, okay, so we have sort of an even split between it will fire or it won't, with delay, or it won't fire, with a slight advantage going to, yes, it will fire, but with 5-minute delay. Oh, even it won't fire. Why? Because basically you have no observation before. So this is your first observation. You don't have any previous samples. So rate and increase in such cases return 0. So we didn't have any metric before. That's why Prometheus didn't notice any changes, because it didn't have anything to compare to. We have several solutions here. We can initialize our metrics, our counters with 0. But this may be difficult when we have like dynamic labels. Or we can rethink our alerting. So instead of alerting on this like greater than 0 anomalies, we can think about formulating SLO, service level objective, around our services. This is, and service level objectives usually in Google SRE workbook approach, they are associated with happy events. So, for example, we calculate how many successful responses we had, and if they fall under like some threshold, then we alert. We alert on SLO breaches. If you are in site reliability engineering field, you for sure heard about SLOs. If you are more in software development and you are not so familiar with those site reliability practices, that's something worthwhile to explore further. Let's move on to our next puzzle, absence. We have a service full, it's down, no metrics scraped at all. And we have this alert like sum of full service up metric and equal, whether or not it's equal 0. And if it's 0, the alert fires. Again, for answers, yes, the alert will fire since Prometheus treats null value and 0 the same way. No, it won't fire. The next answer, there is no metric, it can't fire. C, no, it won't fire because Prometheus will fire another alert on an absent metric. And D, yes, it will fire since the query will throw an error because there is no metric. So again, your choices, and we'll see how it will turn out. Please help me with your choices. No, it won't fire. We have only 2 answers. Some more answers from you, please. Yeah, it won't fire. 5 answers. Yeah, that was the 6. Yeah, absolutely, it won't fire. You are very good at Prometheus. So yes, it won't fire. There is no metric. I've seen such queries in alerts in the real world. So those alerts were not configured properly. So basically, to compare to any actual value, we need to have the metric present, some samples present. If metrics disappear, it doesn't cause any alert. We need to use absent to check on absent metrics. And we had such a problem ourselves in the past when we had SLOs configured and it was all fine and it was all green in our dashboards, no alerts firing, but it turned out that our metrics basically disappeared and we didn't notice that. SLI, service level indicators, which were used in our SLO, basically were not available and didn't trigger anything. So we need to use absent in such cases if we want to monitor whether or not the metrics present at all. And the last one is cardinality trap. If you work with Prometheus, you may have experienced like explosion of cardinality when it comes to labels and metrics. So a quick puzzle on that one. We have on-prem Prometheus deployment. We've added request ID label to our HTTP metrics. And what will happen after 1 hour? Nothing. B, we don't know, we need more information. C, most likely Prometheus out of memory exception. D, the dashboards will be slowed down because we have this unique request ID associated with metrics, so it's gonna take longer to calculate some queries. Your guesses, please. Let me switch to the next puzzle. Yep, and your guesses. Let me know what you think. Most likely, we need more information or all out of memory. Basically, those are pretty good guesses. Most likely out of memory error. Obviously, I would agree with those of you who said more detailed information. We need more detailed information. However, if we have a lot of HTTP requests, most likely we'll get out of memory exception because metrics are stored in on-prem. All metrics are stored in memory, and it will cause this explosion of cardinality for each metric, and it can end really bad with OOM. With high cardinality problem, we have Prometheus deployment becomes very CPU intensive, memory intensive, metrics are getting dropped, or we may end up with very high costs when we use some external provider as our observability solution. So we should avoid unbounded labels like those unique request IDs, timestamps, etc. We need to remember that the cardinality of a metric is the product, and multiplication can cause a very quick growth, and we need to take care about our metrics hygiene and monitor cardinalities of metrics. So those were the most interesting cases I wanted to show you, which we encountered during our work with Prometheus. That's not all of them. Those were most interesting and the most common ones. So it only shows us that we need to know our tools. We can't be a fool with a tool because we would be still a fool. We need to use our tools smart. And that's why we need to continue our learning process, and that's what conferences are for. So thank you for your cooperation and your help. You are very good at Prometheus. That's very good to see. And if you have any questions, just approach me during a break. Thank you.